Hello, good morning. Okay, in fact, it's good afternoon here. Yeah. So once again, let us solve one more problem on friction. This problem, most of the students do not attempt it. They feel this is very tough to attempt and finally they just quit it. I have seen this problem in many of the examinations in one or the other way, but still students have a difficulty in answering this. It's a problem from the book H.C. Verma. Of course, the problem is a bit lengthier, but I have taken only a small part of it. Okay, to make you understand what is the underlying concept. Okay, this problem can be applicable or it's applicable for 9th standard or 10th standard, 11th, 12th, IB, IGCSE, ICSE. For every syllabus, this problem is applicable. Okay, let us begin with this problem. So find the acceleration of the 3 kg mass. Okay, now you want only for this one. If a horizontal force of 10 Newton is applied on the 2 kg. So if suppose if I apply a force here, or apply a force here, or apply a force here, I can apply the force anywhere. Okay, and then I want to find out if I apply a force of 10 kg here, 10 Newton over here, what will be the acceleration? What will be the acceleration of this here? Okay. Okay, so therefore, so towards it, let us start with this. Okay. So now, if you apply a force of 10 Newton here, let us take up one of this object. This is my 2 kg object over here. If I apply a force of 10 Newton, the first question we should ask is, will the object move? What are the forces acting on it? So towards it, what is the force acting here? There is one force acting here, and there should be a frictional force acting here. There's a frictional force acting here. What is the value of the frictional force? That determines of the that depends upon the value of the normal force. So let us write the normal force over here. This is my normal force, and this 2g will act over here, and this is my frictional force. Okay. So now, what is the frictional force? Let us find out. FF1 is equal to mu times n. What is the value of mu1? This is mu1, which is equal to 0.2. So thus you will write 0.2 times what is n? N is nothing but 2g. 2 multiplied by 10, which is equal to how much? 4 Newton. Okay. Thus you see there's an opposite force of 4 Newton, frictional force of 4 Newton, but the applied force is 10 Newton. So as a result of it, what will happen? The object will definitely move. Let us find the acceleration. A1, let me call A1 as acceleration. Okay, which is now the acceleration of this block. Okay, but he is asking you what is the acceleration of the 3 kg mass. Remember, very, very important. We want to find out what is this. Let us do that also. So A1 should now be equal to forward force is 10 Newton. 10 Newton minus backward force is 4 Newton. Because this is acting in the opposite direction. 10 Newton minus 4 Newton divided by mass of the object, which is 2. Right? Because F equal to MA1. So I have taken MA1 should be equal to this one, or A1 is equal to 10 Newton minus 4 Newton by 2, which should be 6 by 2, which is equal to 3 meter per second square. Okay, this much part, everyone does it correctly. But when it comes to this, now here lies the problem. Now, first one is done. Now, if I want to find out here, now you see 10 Newton forces applied here. Okay, of which 4 Newton is already taken over by the frictional force over here, which means 6 Newton has been consumed by this object, because it says, see, I want all the force. Okay, how much ever you want, you can give, but I will take up all of them. But unfortunately, 4 Newton is already received here. Now, this forms the action for the second object. The reaction will be seen here, which means these two objects will now be moved or will be pulled by a force of 4 Newton. Okay. Now, if this has to be pulled by a force of 4 Newton, now as this moves, will this move separately? Let us ask that question also. Now, the problem now reduces to something like you have a 3 kg object. A force of 4 Newton is acting on it. I hope you got this problem, or otherwise assume it like this. See, friction is nothing but you have two surfaces which are interlocked like this. Now, if you are pulling this with 2 Newton, 10 Newton, the upward block is your 2 kg block. If you're pulling it like this, not all the 10 Newton is utilized. Okay, 4 Newton is in the other direction. Only 6 Newton is being consumed by it. Okay, so therefore, the rest 4 Newton this block is also been pulled. Okay, if you ask me how much force does this share, how much force this share, I can say that the of the 10 Newton, 4 Newton is being shared by this object. By this object in the sense this object plus this object. Okay. Now towards it, now the object is now equivalent to 4 Newton has been pulled like this. Though there is a 4 Newton force pulling here, there should be a frictional force here. There should be a frictional force here. What are these values? The frictional force in this direction. Let us find out this one here. So now here I get this as normal reaction. And here for this object, the weight of this one will also get added here. So this will be 5g. Okay, and then you see that this value will now be equal to mu times 5g, and mu value is equal to 0.3. 0.3 into 50, which should be equal to 15 newtons. Okay, I have not taken this into account now. Okay, now here itself, if it is 15 Newton, this is applicable as 4 Newton. So definitely this 3 kg will not move away from the 7 kg or the 2 kg. Now these two will act as one system over here, right? So therefore, now what we should do, we should find out now what will happen to this object. Now it will be this 3 and 7 kg will go together, and this surface is frictionless. So therefore, they will both of this object will go together, which means what? This is your 3 kg. This is your 7 kg. Both of them will start sliding over here together. Though you applied a force here, you expected that this should only go. But now what is happening? Both of them are going. Why it is going? Because the frictional force here is much larger than this one. The coefficient of frictional force, sorry, the static frictional force is much larger. It is itself is 15 Newton over here. Until unless you don't apply a 15 Newton force, this object will not slide away from here. That's the reason why these two have to move together. Okay, either they have to be at rest, but unfortunately here you see this mu3 equal to 0 over here, and as a result of it, these two should move together. Okay, now what we do is now, so if they are moving together, the total acceleration is a2. A2 and A3 are equal here. So therefore, now what do we have here? There's a 4 Newton force acting over here. 4 Newton force acting over here. And then, so because of which now see this whole thing is one system and there's no friction here. So applicable force F applied is equal to 4 Newton. 4 Newton. Now mass into acceleration. What is mass here? 3 plus 7, 10. 10 times A2 is equal to 4. This implies A2 will be equal to 0.4 meter per second square, which is also equal to 0.3 meter, which is also equal to, which is also equal to A3. Which since these two are going together, so therefore the first answer here for the 2 kg block, the horizontal force of 10 newtons applied on 2 kg block, the acceleration of the 3 kg mass would be 0.4 meter per second square. Okay, this is the answer for the first one. Okay, so therefore answer A here would be 0.4 meter per second square. Now let us take up the 3 kg block. Now instead of applying a force here, I am going to apply a force here. If I apply a force over here, now what will happen? If I am applying a force of 10 Newton here, if I am applying a force of 10 Newton, I think I can take up a new slide and show it across instead of making things more clumsier here. Just give me a moment. We'll copy the whole slide and then we will do this. Okay, let us go to the new slide here. Right. Okay, now what has happened? Okay, let me just remove this one. Let me remove this F equal to 10 Newton here. This is only 4 Newton here, right? Okay. Now let me go here. Now here, what is happening? This is force of 10 Newton is applied on the 3 kg object. 3 kg object. That means you are applying a force here. F equal to 10 Newton. Now the question is, what will happen to the two objects, or what is the acceleration of this? Now towards this, let us draw the free body diagram once again. This is your third object, 7 kg object. This is your second object, which is a 3 kg object. On top of it, you have a 2 kg object. You are applying a force of 10 Newton over here. Now what will happen? This will experience a friction due to this. This will also experience a friction due to this, right? Let us find out what is the friction due to this one. This is FF1, this is FF2. Okay, so as a result of this, now FF1, we already have found out what is the value of this. This should be 0.2 into 2 into 10. In the previous slide, we have seen. We should now be equal to 4 Newton. And this one, we already seen F2 should be equal to 15 Newton. So you apply a force of 10 Newton. Okay, there in the earlier case, you applied only a force of 4 Newton. Now you are applying a force of 10 Newton, but the total frictional force is the sum of these two, which is 15 plus 4, 19 Newton. Do you think this will move? This won't move, right? This won't move. So as a result of this, so all the three will be present as only one system over here, right? So it will not move. So thus, what can we say? We can say that 10 Newton is the applicable force. This should now be equal to 7 plus 3, 10 plus 2, 12. 12 kg is multiplied by A. RA should be equal to 10 by 12, which should be equal to 5 by 6 meter per second square, right? So what does it mean? It tells me that when you apply a force here, this 2 kg, 3 kg and 7 kg will go together. Okay, you will not be able to pull this object alone. All the three will be going together, right? So we have got this for the second one. So here it is 5 by 6 meter per second square will be the acceleration for A1 equal to A2 is equal to A3. All the three will be moving in the same acceleration. Why do they move in same acceleration? The reason is because this will be a full system now and there is no friction in the below layer. Okay, fine. Let me take up one more copy of the slide to make it more clearer. I don't want to mess up with the same one. Right. Okay. Right. What's the third one? C now is force is applied at 7 kg block, which means what? You are applying a force here. Okay, 10 Newton. Most of them, once again, they make a mistake saying that if you are applying a force here anyway, there's a small friction, this object will fall down, will go like this, and this two will fall down. No, it's incorrect. The reason is because let us find what is the friction here. Okay, we cannot conclusively say correct or incorrect. Let us find the friction here. Now, if I am applying a force here, the total weight standing on top of it is 5 kg, right? 5 kg over here. So if this is 5 kg, then what can happen is the friction here should be, let me call this as F3. Okay, F3, which will not be equal to 50 Newton. Okay, 0.3 multiplied by 5 multiplied by 10. Ah, wow, it is 50 Newton. No, sorry, 0.3. Yeah, this is 50 Newton only. Good, 50 Newton only, which means this force, the limiting force is much larger than this force. Will this 7 kg move away from here? Definitely no. It is something like if I put my fingers, my hand like this, and I try to move it like this, see, I'm not able to move it because this weight is much larger, right? So therefore, all the three will now start moving together, right? There's a total applied force. Total applied force is 7 plus 3, 10 plus 2, 12 Newton. Okay, sorry, 10 Newton. Total applied force is 10 Newton. This should be equal to total mass. What is total mass? 10 plus 2, 12 kg multiplied by A. RA should be equal to 10 by 12, which is once again 5 by 6 meter per second square. Okay, which tells you that the 3 kg object will also move with the same acceleration, which is 5 by 6 meter per second square. Okay, so this is the way how you need to solve it. If you want, I can just once again show you what we have done so far. The first one, what we have done is we took the mass of 2 kg and drew a force diagram here. Normal force is upwards, 2g, the way gravitational force is downwards over here. Applied a force of 10 Newton, frictional force is acting here. First thing, what did we do? We calculated what is the frictional force here. So how did you calculate? F is equal to mu times n. Why did you use this? because we assumed that the object is moving in the forward direction. The 2 kg object is moving in the forward direction. Why does it move? Because you applied a force of 10 Newton. So now you see mu1 times n, which should now be equal to 0.2 into 2 into 10, which should be equal to 4 Newton. Which means what? The opposite force acting on the 2 kg object is seen to be 4 Newton, while the forward force is seen to be 10 Newton. So definitely forward force is larger than the opposite force. The object should move like this, right? Thus you found out what is the acceleration of the 2 kg object, which came out to be 3 meters per second square. Anyway, that has not been asked. Okay, we need not find this one. I just gave it as a sake of completion. Then now if 6 Newton has been consumed here, right? See, though you applied 10 Newton, 4 Newton has been consumed by the whole system here. This is now one system. How do you define a system? A system is one wherein all the objects present in it are moving together. Okay, or all of them are doing the same work. Okay, so but a object which does not belong to the system is a 2 kg object. Because you applied a force, it says, okay, I am happy, I am going, you do whatever you want. Right? So therefore, this is a separate system. See, in physics, separating the system is an art. So if you know this correctly, you'll be able to solve every problem. Right? So therefore, no. So therefore, 6 Newton is consumed by this, and 4 Newton is remaining over here. Now this 4 Newton is now acted upon on the both 3 kg and the 7 kg object. Now you should ask, since 4 Newton is given here, what will this 3 kg and 7 kg do? Will the 3 kgs get separated from 7 kg? It depends on how this 7 kg is holding it. How does it hold? By friction, right? So friction coefficient mu2 equal to 0.3 is given. So therefore, now what you do is you find out what is the opposite force here. Okay, if you find the opposite force, now this is my 3 kg object. This is the opposite force acting here. So what is the opposite force acting here? Opposite force acting here should now be equal to 0.3 multiplied by 5 multiplied by 10, which should be equal to 15 Newton. Now, how much force is acting here on both the system? 4 Newton. Poor fellow, 4 Newton is only the force given to it. Okay, but it has to overcome the 15 Newton. Will it be able to go? No. So as a result of it, what will happen? Okay, so these two will stay together, but still you are applying a force. It should do something, right? So if it has to do something, then this 4 Newton will be applicable on both the objects, and as a result of it, both of them will start trying to move away. So they start moving like this. Why should both of them move away? Because you see, when you are not able to move only 3 kg object, why should it, or how should it move the 7 kg object? This is a question everyone has it. The reason is because here there was a friction. When you consider the whole system, there is no friction at all here. So as a result of this, you can expect that both of them will start moving. And based on it, we found out the net applied force is 4 Newton, no friction here. And then 3 plus 7 is equal to 10 kg. So 4 Newton equal to 10 kg. 4 Newton is equal to 10 kg multiplied by A, or A2 should be equal to 4 by 10. Thus we got this acceleration. Okay, the first part is a bit tricky. Okay, if you understand the first part, the rest of them are quite easier. The second part, what did we do? Second part, what we did was you applied a force of 10 Newton here and asked the question. See, I am applying a force of 10 Newton. Who are my opposite forces? Just like tug of war. Then what happened? So the opposite forces here were much larger than the 10 Newton. So maximum force required was 90 Newton. So you are applying only 10 Newton. Definitely the object cannot go beyond it. So all the three will start moving together. Thus, each one of these objects will have the same acceleration, right? Quite easier to understand. The last one, what did we do in the last one? The last one, we applied a force of 10 Newton here. And then we asked the question, what is the friction acting here? The friction acting here was seen to be 15 Newton. So which is much larger than this. So you cannot expect that this will go away from the system. So all the three is now in the system. Thus, this 10 Newton is made to make all the three objects start moving, which in such cases, the acceleration of each of this object is equal. And as a result of it, A is equal to 5 by 6 meters per second square. I hope you understood this problem. If you don't, you can just put across your comments in the YouTube, and I'll definitely be happy to answer to this. Thank you, friends, for watching this. So in the next class, in the next video, we will see some more problems and some complex problems on friction. Thank you.